scientific notation with positive exponent. All right, so scientific notation is when you have a number, and this number needs to be between 1 and 10. It can't be 10, so you want one digit, then a decimal. There could be more decimals here. Decimal point, and then decimal numbers. And it'll be multiplied by 10 raised to some power. In this topic, this power is going to be positive. When you're going from scientific notation to standard notation, and this one right here, this is already written in scientific notation, that's what I was just talking about. You could put this in your calculator. You could put 1.977 times 10 to the third in your calculator and it will work, but let's talk about doing it by hand because it's not that bad. If you have a number in scientific notation and this exponent is positive, that means you're making the number bigger. So positive exponents on 10 make numbers bigger. Negative exponents on 10 make numbers smaller. Like I said, in this topic, we're just going to be dealing with those positive powers, but in another topic, you'll deal with the negatives, so it's good to know. So if you have 1.977 times 10 to the third, you can think of this exponent as telling you how many times you need to move your decimal place. I need to move my decimal point over 3 places. I want to do it in such a way that it makes this number bigger. If I moved my decimal this way, I would be making my number smaller, but if I move my decimal over this way, it'll make the number bigger. So I want to move the decimal point to the right 3 times. 1, 2, 3. So I would have 1977, and technically there'd be a decimal point here, and you could put a 0 if you wanted, but since it's unnecessary if you don't have anything after it. You would just have 1977, and that is your answer in standard notation. Sometimes they're going to ask you to go in the opposite direction. So this is a number written in standard notation. And we want to put it in scientific notation. When you're putting it in scientific notation, you're looking at moving the decimal point right before the first number. So I want this decimal point to go right here. I want to move it 2 times. If I moved it 2 times, I would have the number 1.889. Next, you're multiplying it by 10 raised to some power. This power is going to be the number of times you moved, and it will be negative if this number was small to begin with, and it will be positive if this number was big. So 188, we consider that a big number, so it'll be a positive exponent, and we moved the decimal 2 times. So 1.889 times 10 to the 2 is the same number in scientific notation. Let's try again writing this in scientific notation. This one looks a little bit different. So we have 97,800, and you might say to me there's no decimal point here. But you can always put a decimal point in. That's no big deal. We want to move the decimal point so it's right after that 9. We would need to move the decimal point 1, 2, 3, 4 times. If we did that, we would have 9.78. Once it's just zeros, so it's just zeros from here on out, you don't need to write those zeros in. So I don't need to put a 0 and a 0 here because it's just zeros the rest of the way. Times 10 raised to our original number was 97,000, which is a big number. So big number means positive exponent. And we moved our decimal a total of 4 times. So this will be positive 4 as an exponent. So 97,800 is the same as 9.78 times 10 to the fourth. So in these ones, you'll just be switching back and forth between standard notation and scientific notation. It's going to give you a little bit of each. Just remember, big number, positive exponent, and then it's just the number of times you moved your decimal point. You got this.